Are you taking the can or the glass?
I don't know. I think I'm gonna take the can because they.
That's what they recommend.
I didn't
You
realize.
did a shit pour though.
Sorry, I didn't realize this was a double. I didn't realize this was a double IPA.
It's 8% though. You know, it's not 9.
Oh, it's not 9.
You know, doubles are usually 9 or 10. All right.
Cheers.
Cheers, man.
Our first live episode.
Chris Wren in New York.
It's kind of unnerving having you like right here, this close to me. What are we
I feel like you're gonna say something different from what you normally say. When you don't have to look me in the face.
You got a very intense glare, you know.
What are you talking about? So today we're talking about whether geospatial platforms are dead.
Geospatial.
Or platforms are dead.
I mean, I don't know.
Or platforms are dead.
What's a platform?
That's a good question. Let's talk about geospatial though.
Sure.
A set of APIs that lets you compute things in a
Like a pre-canned way, maybe.
in a simplified way. That's a bad answer.
So it's like, okay, you have a bunch of data, probably object storage, and you have like a bunch of compute somewhere to do operations on the data.
Mm-hmm.
And is the platform the data, the compute, and the APIs, the software that lets you...
It depends on the platform.
Okay.
Right, because not every platform has a catalog, for example. Right?
What platform doesn't?
Maybe all platforms have
I think the
catalog.
catalog is kind of...
Because you're indexing against the catalog?
Yeah, and it's like, oh, we make this cheaper because... and fast to access.
Mm-hmm.
Because we organize the catalog in a certain way, because it's cogs indexed this way, or ZAR source indexed this way.
Mm-hmm.
And the catalog is like the metadata to help you find those things, but that's not the platform. The platform is like... I think it makes sense that you said API first, because like that's the entryway into it. But the things you end up interacting with, like let's just take Earth Engine or Planetary Computer, which I've never used. It's when you look at their notebooks, it's like use the Planetary Computer and then use Stack also, which is like maybe the metadata for the catalog, and then you can run some computation, some pre-established computation like median and DVI over all of these pixels over all of this time series. And that triggers a computation that goes and fetches the right chunks at the right locations, runs the computation, and you get the result. Right?
Yeah.
So it's like data, compute, and API, like the interaction.
Data, compute, API. But in the case of Stack, so Stack is a specification, right? It's like a specification of this is what metadata should look like. Mm-hmm. And if you conform to your metadata specification this way, then other things will understand how to read that in a standardized format.
Right.
Like, so like in the
way of organizing.
Yeah. So I mean, in that case, the metadata is not part of the platform, right? I'm trying to draw some delineation of where I think the idea of platform differs. Mm-hmm. And I feel like with the Planetary Computer case, it's like it was a version of a platform that was way more stripped down, that relied on we're using the Stack specification. Mm-hmm. We use, I hope I don't have this wrong, we use Dask to do our compute.
Like the backend.
And this is the way we're chunking with stuff in Azure Blob Storage. Yeah. In that sense, it feels very different from something like what the Descartes Labs platform used to be or what Earth Engine is. But is there functionally a difference? Or am I thinking there's boundaries here, but there aren't actually boundaries?
I think I think like definitely there's functional differences between all of those platforms. Okay, but maybe the thing that unifies them, which is what we're trying to define,
Sure.
is that some executive had a really big plan to scale. I feel like it's like the scale, right? It's like the idea planetary scale computation. Like that's always been the idea.
You cannot do a planetary scale computation yourself.
You couldn't
So
possibly.
you need a platform to help you do
You
it.
need a platform. It's just too much data.
Yeah.
It's like too hard to access.
Yeah.
We need to design the API for you.
Yeah.
We need to design how it's going to parallelize.
I mean, is another way to say what a platform is a wrapper around cloud-based orchestration?
Yes, that's exactly it.
It's just a wrapper around the fact that you don't want to write all the specific AWS Lambda code yourself, and you don't want to write all the tiling code yourself using
You don't want to organize the storage
GDAL
yourself.
and yeah, exactly. And you don't want to build your geospatial index yourself of all the data that already lives in.
Yep.
Is that what it is?
I think there could also be like proprietary data on the platform, right? Like I don't know.
Sure. But ultimately
I think
that data is just data.
Ultimately, I think it's a premium you pay for convenience on top of a cloud platform. Yeah.
I'm trying to think if there's any situation in which that is not the case, but I can't think of anything. So this is something that is, so we're saying that this is something that is sort of inextricably linked from cloud services. But like, let's take ArcGIS and Esri. Esri is a platform. ArcGIS is a platform. I believe like that stuff has existed for a long time, right? And so did that, I mean, that was a platform that existed before all the cloud compute stuff. It was like a Windows thing. And I think in the early days there wasn't all this. Like maybe you still access some data from some servers that lived somewhere, but I think it was more like a local QGIS thing. I mean, QGIS you can pull data from anywhere now, but do you know what I mean?
You were just like streaming the data into your desktop application.
Basically. Yeah. But like it is a platform, and these days it is a platform. They have there's APIs, there's Python libraries, there's like it's a desktop application, and it does cloud-based orchestration.
So maybe another way, like if we strip out the cloud bit, it's a way for you to rent data and compute at a premium for convenience from someone. Even whether that data and compute is on premises for them, like the source isn't as important. It's just because it's been very cloud-based recently.
And with the case of ArcGIS, the reason it has a moat and the reason people use it is because it's processing toolboxes. It's ways of doing processing on raster and vector data.
I've never used ArcGIS.
Like imagine like raster stats or but imagine also like segmentation. Like now you can do like segmentation in ArcGIS and like run, and it's just like it's just UI based. You're like, I want to segment this, and it like quote unquote works. But I mean with that, I feel like the reason people use it, part of the reason people use it is because they know how to do all the processing steps and the computation, the little bits of computation. They don't have to implement that stuff themselves. It's already there. Yeah. And platforms have that. Other platforms have that too. Like Earth Engine has sets of computations that you can do, right? In that sense, it's not that different.
Right.
It's just more like, it's point and shoot.
But like does the computation happen on your laptop, or does it happen somewhere else?
No, I think it happens somewhere else and gets sent back. I think it depends. I think it depends if you're working with a local TIFF file, but I think you can do it on huge, like imagine Sentinel-2 Landsat style archives that live in Esri.
In ArcGIS.
Yeah.
Wow.
And you can run calculations. And Esri, I think, is like a Microsoft on the back end, so it's all like Microsoft.
So it's like
Azure. Yeah.
But maybe it wasn't until
exactly
until Azure existed. But
so what is a platform?
We still don't know. Talking about desktop applications over here.
I'm trying to
Like,
draw boundaries around all the things that I think are platforms and trying to get to the
but like the
common thread.
the big picture is that you're
I
like
think-
renting
Yeah.
data and compute, some combination thereof, at a premium for like the convenience of an API, the convenience of like
Okay.
someone having done the hard work to link the data and the compute
Yeah.
together,
Yeah.
calculate like a set of computations that one might want to do together, like reduce region, percentiles, like these kinds of things.
In that case, it's like building a model of what cloud-based GIS operations look like and how
Yeah.
you chain those together with these set of classes
Yeah.
that conceptually represent important pieces.
Yeah.
Like going from image collections to images to feature collections, like that chain of operations.
Yeah.
Yeah.
So,
Okay, so that's a platform.
okay. Probably need to repeat that definition a couple times. But it's funny actually going through this exercise of like what actually is it, because people will throw it out and you're just like, oh yeah, like, oh, this is a platform and this is.
This is part of the reason I feel like the reason this is a difficult conversation is part of the reason why platforms don't have that much traction.
Because it's like thinking about the shape of the thing. As
What
opposed to
exactly does it do?
What use it serves.
Yeah, right.
Yeah, it's like becoming obsessed, and obviously it makes sense too, because you can charge a subscription, you can build a subscription-based
Right.
business around the platform, and investors love that, as they should,
Yeah.
right?
Yeah.
And it scales with like usage, and
Yep.
you enable so much usage that the upper bound is high compared to like selling solutions.
And if we if we take ourselves out of the current moment and go to 2018, when like the Descartes Labs platform was a thing, when Earth Engine was a thing.
I mean, Earth Engine is still.
No, it's still
Sure.
a thing. Yeah, but
It was becoming a commercial.
Yeah,
offering.
sure.
I guess it wasn't.
But like, I feel like back then, the value seemed like it was hard to grab some of these data sets, right?
Yep.
Like I'm trying to remember the exact date at which
It's like on the
the Landsat and the ESA, like Sentinel-2
Yeah.
and Landsat were in S3
right.
as part of their like AWS
Yeah,
for public
that was
good.
like-
it was after that, right?
We have already asked this question, and Rick Chartrand actually wrote to me to say this was after that, definitely, and maybe in like 2020 or 2021 or something like that. Yeah. Yeah, I mean the AWS Open Data Program is kind of amazing, actually.
Yeah.
I always felt like, oh, AWS should build their own Earth Engine, because but actually now I'm realizing, and I guess this is what we said we were going to talk about, is that if the data is in object storage and like well indexed, documented, then now
And all the AWS datasets have stack specifications, super
Yeah,
easy to browse.
so easy.
With like a stack browser, you can look through any of
Yeah.
that stuff. You can throw it on a map. It's
Yeah.
all pretty easy, right?
it's just so easy to send an agent to crawl it and
Yeah.
find the thing you want to find.
Yeah.
And there's so much work that goes into like optimizing data access patterns so that you can serve many people.
Mm-hmm.
But now people can optimize their own specific
You just
data
build the
access.
specific thing you need to do.
Yeah, I don't need to. Maybe I don't care about deploying a unit. I just want to do like NDVI time series or something like that.
Yeah.
And you can optimize in that sense, and I mean, you could argue that like with the open data program, a lot of the value already went out of like, we're going to ingest this data, have it in our own private catalog so you can access
Right.
it.
And maybe the one thing I would say is that like at the time I do think knowing how to use Kubernetes,
Yeah.
learning the ins and outs of particular cloud platforms and how to do the orchestration,
Yeah.
like that was a specialized skill set.
Yep.
Like there were people who knew how to do that, and then there were a lot of scientists who
Just wanted,
didn't know how to do that and didn't want to know how to do that. Like
Yeah.
that was like,
Yep.
you know, that was not the thing they wanted to do, and so that was a legitimate barrier, I think, for a long time.
Especially for doing things
Like
at scale.
like looking up all the AWS documentation and stuff sucks.
It really sucks.
You know,
It-
and then you're trying to do it on Google Cloud, and it's different, and,
Yeah.
and all the constraints are different, right? And
Yeah.
and all the the patterns are different, and so I think that was a legitimate barrier, and so I think I could
It
at
was.
least see the argument
Oh, for
that
sure.
platforms made a difference. I mean, when I was at Descartes, when we used the Descartes Labs platform, it's unclear if I was objective in knowing what the true value of it was, because it's the only thing I knew. But it felt valuable once I knew how to use it. I was like, oh, I don't,
I didn't
you can
know.
you can sort of arbitrarily scale
I
computations.
couldn't do
and
this before.
I couldn't do this before, and now I can do it. And then, I mean, so I feel like it felt valuable. I just wonder if, let's say the Descartes Labs platform was being built now with raster and tasks and all that stuff. Let's forget workflows for a second. Right now, would that particular product be valuable?
Well, okay. Valuable, you mean commercially? Or would it
Would
be
you use
useful?
it?
I
mean,
for free.
I don't think
I mean, I used it for free to begin with.
No,
and
but
then-
would you use it for free now, or would you just go to the source and
like
do
with
it
the-
yourself? That's
with
kind
the-
of what I mean. Yeah.
I think if it was free, I would use someone else's computer and store and egress, right? Like I think.
Okay,
that's,
but what if it's not free?
okay, if it's not free,
What if it's $20 a month? What if it's $50 a month?
but I can run. Like, are we talking like this is basically like a Claude Max?
Or like, what if
plan?
it's something like Wearabots, where it's like, you pay for what you use?
I think
So if you run global scale, I mean, this is stupid, but if you run global scales, like
embeddings.
on 50 centimeter imagery.
I mean, I don't think that's. We could talk about. I don't think that's.
I don't know if
actually-
that's stupid
I
or
don't
not.
think
Okay,
that's stupid.
you're the one that said embeddings. I wasn't gonna say embeddings.
Okay, you were.
I was gonna give some high res.
but-
I was trying to think of an example where it's like you would need actually a lot of compute.
I think like. I think scaling is still non-trivial yourself. So if you did need to do something global,
Yeah.
right? And you were a bit impatient, you didn't want to wait, and then retry, like figure out your own retry schedule of the fail tasks, and like I think there is I think like as you scale, the problems are like problems squared, like it's like there's just so much shit that can go wrong.
Are you ever doing something global in which you just like want to do it really quick?
I'm not.
Should anybody be doing that? No, but it's like,
Yeah. I see
because
what
like
you mean.
the cost of validation and knowing whether the thing is working scales
Yeah.
quadratically with
Right.
the amount of
Okay.
is it quadratically with the size of your AOI?
Right.
So if your AOI is the whole world,
Mm-hmm.
then and you're just like, I need to do a global run.
Yeah.
Do you know what I mean? It's
yeah.
like at that point, why wouldn't you be taking the time to
Right.
build the thing from scratch?
Okay, so the question is, being a rational actor.
I'm
would
saying
I-
being a realistic practitioner.
Yeah, I think
I don't know about fully rational, but like you are a practitioner.
I think there's like how else would I do it, right? Like I would
Yeah.
probably spin up Claude, you'd probably like point it at some documentation, maybe like tell it the steps, things like that, and like things can go wrong doing that,
Of course.
and that is still work at this point. Maybe
Yeah.
next year it won't be, right? But right now it's still work, and like but it's also still work to familiarize yourself with the platform. So I guess it's not. The answer is not obvious to me. It's not obvious.
I guess to make it more tangible, I've already talked about this before on the podcast, but like the Impact Observatory land use land cover map, when we did that, we did it global, and we didn't use a platform.
Right.
Like the marketing language was like planetary computer. It was literally files and blob storage.
Yeah.
That was it.
Yeah.
Which is the same thing as like the Open Data Archive, right? For
Right. Yeah.
That's on S3.
Yeah.
And so it was like a thing that was built to custom do a thing, right? Like what we were talking about, this is like there's no general utility of this. This just does land cover. It doesn't do anything else.
Right.
It's built to do land cover. It was work.
Yeah.
But I think that particular nature of the amount of work it took then would be less now.
Yeah.
Like fairly significantly. Because a lot of it is the how do you, what's the what cloud orchestration bit am I doing?
Yeah.
Like how am I chunking each little piece of work? Should I be running it on a CPU or a GPU node?
Yeah.
And then where are these files going? And then how is everything coming together? And then what's the next step? Do you know what I mean? It's like,
but the question is, which one would you choose? It's not just dependent on like level of effort. It's like, am I going to rerun this? Is the computer storage provided at a discount because VCs are funding it, which often they are, or a big company's funding it because often they are, or are they trying to like capture market share by being cheap? In which case it makes sense to use it maybe, and not pay for the compute. And
you have some credits
yourself.
You have unlimited credits for a year or whatever.
And often a lot of these ways, just economically speaking, the way these platforms operate is like at a loss.
Yeah.
They're not going to charge you a fair market price because they're just trying to get you to use the thing.
Yeah.
And so I think that's what complicates the equation, right? It's like, okay, like, what are we going to do with this thing? We're going to rerun it every year? Like, do we have like a guaranteed set of credits from these guys or whatever? Right?
Here's a question. Here's a different question. So forget the cost.
Okay.
Totally. Let's just think about it purely from an ease of use standpoint now. Is it easier to learn how a platform that you haven't used works and like figure out how to adapt your problem within the framework, the conceptual framework that platform is built on? So if you're doing something in Earth Engine, it's like figuring out how to map it to image collections, images, feature collections type thing. Yeah. If you're doing it in Descartes Labs, it's a different model, right? Like how do I scale my tasks and do this, and what's each of the tasks doing, and what's the most efficient way to do that?
Right.
Like both those ways have like specific ways you have to think about the problem and specific ways you have to write the code.
Yeah.
Like, is it now still easy? Is it easier to do that, or is it easier to just conjure the conceptual framework that makes sense to you and implement it yourself, like quote unquote from scratch
with an LLM?
With an LLM.
And in this scenario, I can't use the LLM to figure out the other stuff with the platform.
I guess you could.
Right?
Yeah, I guess you could.
I think that's the thing. Is
yeah.
It's really. I think it all like. I think you can't forget about the cost because that's kind of what it's about, right? Like, and then you factor in your own time, and you factor in like, is the LLM better at writing like AWS Batch and Lambda code, or is it better at writing Earth Engine? I bet it's better at writing
AWS Lambda.
Yeah. But I would still not that obvious to me. Still not like.
So is it safe to say that because when you do it custom, you optimize for your use case, so it's cheaper than if you use a platform which is almost definitionally general purpose? So it should be cheaper, right?
I just think that there's always like a bit of pain. Like, have I done this before and I'm just re-implementing it? Or is this like a novel workflow that I'm trying to figure out? Because I think there's always pain in the novelty, whether you use an LLM or not, and with the platform, I feel like maybe there's more guardrails around the bad surprises. But
is it safe to say that a good platform has done some of the hard thinking for you to bound your problems or bound the computation of your problems?
Yeah, I think so.
Or place boundaries where you might not have thought the boundaries should be, but like
Yeah.
the design of the platform informs the boundaries
Yeah.
in a conceptual way.
I think so. All of this is colored by like my recent experiences with Claude. Uh, you know, I've been jokingly saying that it's been lying to me, but just like having like some bad surprises, like thinking like, oh, this thing can do anything, and then figuring out that actually there's a fair amount of hand holding involved.
Mm-hmm.
There's like it's not one shotting this.
No,
thing,
yeah,
like,
yeah.
especially at scale.
Yeah.
Especially if I'm paying for the compute.
Right.
And
Right.
I'm thinking about how to parallelize it, or it's helping me
Right.
work through that problem. And so, what the platform sells ultimately, I think, is like convenience, right?
Mm-hmm.
And I guess what we're talking about is like, do the LLMs replace some of that
Yeah,
convenience?
yeah. I think that's a good way to frame it. Do they?
And I think they replace
some of it.
some of it.
Yeah.
But you could also feed the LLM the platform documentation.
Sure.
And then it's like, that's more convenient, and like you're using someone else's compute. But I do think that like there's a lot of, I think what's tricky with the platforms is like, I think it's pricing.
Yeah.
It's like, how do I make this appealing? How do I make this worth the effort?
Yeah.
How do I make this appealing? But also, how do I recoup all the costs I spent on engineering and being clever and the engineers I hired
and make money
off of this thing, right? Because you're selling convenience.
Why does nobody want to pay for platforms? Or like, I don't think a lot of people have figured this out.
For geospatial.
Yeah.
Because no one's making money.
Because there's no commercial market.
I just think like...
No, but is it like there's not enough users, or the types of work the platforms are offering you to be able to do are there's just a limit to the amount of total like market share of that, or like what is it, or is it just that everybody's doing stuff by themselves and you don't want to pay for the platform?
I don't know. All I know is when I worked briefly as a Google Cloud reseller, including
that's right.
including Earth Engine as a service.
Yeah.
Many of those companies that were potential clients or were interested or were actually paying users of that whole cloud ecosystem, including Earth Engine, were not profitable.
Yeah. And a lot of those companies have since
gone out of business.
Yeah, right.
Or gone through financial hardships, and Earth Engine was expensive. Actually.
Yeah, right.
It was expensive. It was
Right.
expensive to do stuff on Earth Engine.
Yeah.
And
Earth Engine has tightened up recently.
it's tightened up.
Like the whole, they've moved. They have these tier selections now, and it's like there's the partner tier at the one end, and there's the,
which makes sense.
Makes a lot of sense.
Everyone's strapped for compute right now.
Right.
And it makes a lot of sense for a company that's like in an AI race.
Yeah.
Yeah,
you gotta save where you can.
Yeah, and so like I'm not saying it. I just think that a lot of the companies, like, you want to do something. The platform enables you to do a difficult thing, which is scaling. Right. But if you scale an unprofitable thing, it just becomes less profitable. Right? Like you're just finding a better way to give money to cloud.
So maybe the
providers.
reason nobody wants to pay for platforms is that nobody has actually figured out profitable, like, Earth observation commercial businesses yet.
I mean, I don't think that's, maybe few have figured out profitable Earth observation analytics businesses that would use a platform.
Yeah.
As opposed to like, we just need storage for imagery.
Right.
And an API to serve it.
Yeah.
Which is still a huge problem. a huge technical problem. But it's like it's true that the analytics space is I don't know. Like it's hard to think of like a company that's raised VC funding that is like successful off the top of my mind.
In analytics.
That pure analytics
Pure
doesn't own a constellation.
Yeah.
Oh, maybe Privateer.
Orbital Insight.
Orbital Insight. Yeah, maybe
Orbital Insight.
Maybe Orbital Insight.
Counting cars in parking lots.
Ships. Maybe.
Ports.
Yeah.
Right.
Maybe,
And there's actually all kinds of commercial companies who are doing shipping and
yeah. So
activity monitoring, right? That intelligence-y type stuff.
And so, you know, maybe there is like, but then it's like, you know, I'm trying to run like YOLO V13 or whatever the latest iteration is on imagery.
I mean, do you think those guys are building? I mean, my guess from the posture of these companies is that basically they've got their custom in-house workflows for like, we get imagery from these data providers, we run these things, we produce these outputs, we then our customers get data in this format. Like it's there's no like platform that they're paying for in that, right?
And I think the reason is like, maybe this is like a survivorship bias or whatever. It's like the companies that are maybe still successful or profitable or have survived to this day have been doing it for a while.
Yeah.
Since before people started being like, oh, you need planetary computer, you need Earth Engine, you need the They've
been doing the hard work for a while. They're like, how do you scale this?
How do you scale this for our specific problem?
Yeah.
We only care about coastlines and things like that.
Probably because they figured out the actual things they need to run. So then it's, you got to be like, okay, this is the thing I actually need to scale. Not just like, I want to scale anything.
Yeah. But I think it's already been getting more and more accessible to people to just do this stuff on their own.
Yeah. There's more imagery than ever.
Skytruth, you know, like there's Sentinel-1 pipeline. And so,
with Cerulean you're talking about? Yeah, Sentinel-1 pipeline. Yeah, for sure.
And it's
they know exactly the thing they need to solve.
Yeah. And they're like, it's cheaper for us.
Yeah.
Rather than like signing up for something and then like next year the prices get jacked up.
So they're not running on Earth Engine.
I don't think so.
They built their own thing. Wow. Okay.
I don't think so. I think they have their own Sentinel-1 pipeline.
Cool.
Great. Yeah. So I think part of that is because like running a computer vision model.
It's expensive.
Via Vertex.
Yeah. It's always a pain in the ass and it's expensive.
Yeah. I mean, I don't know if it's still expensive, but it was
definitely a pain in the ass.
2-3 years ago, it was hard. It was non-trivial, I would say.
Right.
But yeah, I mean, but like I don't know if the difficulty is in like writing the code to do it. It's like thinking about the patterns, and I still don't know if Claude is great at that.
Yeah, no. If you just give it an open-ended problem with no guidance on the way it should be solved, it's just gonna just fire off, you know? Start doing stuff.
But I think it's still the scale. Like, if I only care about a small area, then like, I'll use Claude all day. You know, like this is not a problem.
But here's a question: so, like, if you're just doing routine, like, composite type stuff, or like routine, like temporal analysis that with the Earth Engine you take for granted, Earth Engine as a platform. Would you be spinning that up every time, or maybe you would be with, I think I was telling you earlier, like, ESA, they czarified all their data, right? So that's like all that's all like consistent, and there's a single way to access it. I'm just thinking about like my go-tos, like, I need to look at this and like, turn to Earth Engine, and easy to pull like a year's worth of data or whatever and do whatever I need to do, check out whether a signal's there. I'm just trying to think, like, would that actually be just as easy using some of these other things?
Well, I think the question, one thing that comes immediately to mind is like, how much do I trust the native co-registration of like everything that's on this bucket. Because like I feel like with Earth Engine, it's like I can
Well,
just-
Sentinel-1's not a good example because the Sentinel-1 data on Earth Engine is fairly garbage compared
Yeah,
to what's
right.
on ASF and
Right.
what's on like Copernicus browser, and so
Is it?
yeah, I think that the Earth Engine
problem.
data is inadequate compared to the source
Because like
for
the-
Sentinel-1
for
Sentinel-1.
co-registration stuff.
Not co-registration stuff, but like they do those like weird log scaling stuff. There's no
Another-
SLC data.
Another platform
Fucked
fucked
you know,
up the
like the
scaling of
GRD data,
Sentinel-1.
like even the GRD data on Sentinel-1 in Earth
Okay.
Engine is a little weird compared to like if you're
Okay.
just pulling it from ASF. Like
Oh wow.
there's
okay.
just things that they do that I think are.
Mess with the data.
I don't think this is controversial to say, but yeah, the Sentinel-1 data on Earth Engine is suboptimal. But
Okay.
not the case with Sentinel-2. I mean
Right.
just
And the other things you might want to
yeah,
intersect
yeah,
it
yeah.
with.
Just Sentinel-1's a bad example. It
Yeah,
triggered
yeah,
me.
yeah. Yeah,
But yeah, the question still stands.
yeah, when we started this, I thought it was going to go in one direction, but this is like, it's, yeah, like, what's the value? Yeah, what's the value? Like, how does this make your life easier? Maybe,
So what is this co-registration stuff you're talking about? As in stuff from the
Like-
source is not co-registered
I
properly?
don't know, like, you need to,
I think that's just like if you're pulling L2, you think there's still issues? Like there's
I don't know. But it's like, do I,
yeah.
like, if I pull a time series,
Sure.
do I need to pull, like, neighboring pixels and do some, like, total variation regularization across the time stack to make sure that, like, everything's matched up across the time series? Or do I think this is...
I think this is a good time to check out what some of these other offerings actually look like. But I think
Like
I feel like
whereabouts?
no, I just mean like looking at the source,
Right.
like
I've not...
like
yeah.
looking at the czar stuff from ESA. Like
Yeah.
I think all that stuff is perfectly
Do
co-registered.
you think it's perfectly...
Yeah,
Okay.
I think.
Well, I think for the time series stuff, if it's a czar store,
Yeah.
it's...
No, but I
Uh,
don't know how much Earth Engine
I don't know.
ingest is doing on that side of like fixing co-registration errors. Like I think this is like
Sorry, I think... okay, but then, like, the intersection of, like, your time series with another raster product... at a
That's
different
what you're talking
At
about.
a different
That's
resolution.
what you're talking
the,
about.
The pyramiding
Oh,
and, like,
I
you
didn't
know what I
realize
mean?
that's what you're.
You
I
know,
know
like-
exactly what you're talking about.
like-
So let's say you have like a modus pixel, and then you're trying to do like modus time series, but then you have like Landsat observations in there. It's
Yeah.
like what does that like reduced resolution operation look like or something? Is that
Yeah, like
kind
at-
of what you're getting at?
At the greenest time step in a modus NDVI time series,
Yeah.
what is the standard deviation of the Landsat pixels in that
Yeah,
modus?
I got
At
you.
that time
So
step.
is it all fitting in? Is it all gridded appropriately in the
How
right
do-
projection?
how do-
Is
yeah,
it,
yeah.
what's the reprojection
I
that's
think-
happening on the back end? Is that what you're talking about?
Yeah, I think that stuff
Yeah,
is the
no,
stuff
I mean
that
that's
Earth
the
Engine-
yeah, it crushes all that shit.
right. I don't have to think about it.
Yeah,
Rarely. And
I mean this is stuff you have to think about all the time when you're doing stuff by yourself. Like even
yeah.
going back to the impact observatory example, that's the only example I have.
Uh-huh.
But it's like we had to think about what the UTM tiling system is.
Yeah.
How are like the boundaries across UTM zones?
Yeah.
How do you handle those? Yeah, you have to think about all these things that you don't think about as
Right,
much.
LLM
LLM will not
not solve it for
think
you.
about that. Yeah.
Not solve it for you.
No.
No, but
It'll just do everything in WGS84 and call it good.
it'd be like, this is the area. This is the average. Huh.
So maybe there is a place.
Right, but like, what would you pay for that?
Yeah.
Is the question.
Right.
Right, like and also like, it's not like these platforms are like seamless user experiences. That's not how I would describe.
They're all
Earth
kind
Engine.
of shit.
It's painful.
Yeah.
They can do amazing things, but you have to suffer a little bit to
Yep,
figure out
yep.
how,
Yep.
like the pain of like launching a bunch of Earth Engine tasks
Yep.
and being like, all right, this will probably be a while, and
Yeah.
waking up and being like, computation timed out,
Yeah.
or I think
Yeah.
so. I think there's still pain in using the platforms as well.
Huh?
But I do think that if the people at Google, on top of Earth Engine, also just opened up the catalog, like here are the buckets
Huh.
where things are,
Uh-huh.
and like here's a stack catalog over
Uh-huh.
like, um, I think they would end up using less compute on their side.
But would they lose their moat? Like, imagine them opening up. I'm thinking of the Earth Engine specific stuff. Cloud Score Plus.
I don't know that they still think, like Alpha Earth is on source
I know
code
Alpha.
now,
Yeah.
and
Yeah.
that's something that I thought was going to be like
Yeah.
I think it's
Because they just want people to use that
I think it's about
so
adoption.
bad. Yeah.
Because going back to your question earlier when you were like, would you want to do something at scale and validate? Like, well, the other thing you can do is do something at scale and have the rest of the world validate
Yeah.
by releasing it for free.
Yeah. Yeah.
So, yeah. I mean, but I do like through all of this, like this idea of like, let's just put everything on cloud storage and have it be open. Like, Jed and Source Co-op were kind of ahead of the curve on
Yeah,
this. Like,
for sure.
And
For sure.
And cloud storage was like, like a lot of scientists didn't know how to like. Well, I have to pay to access this like AWS bucket. What does
Yeah.
requester pays mean? Like, how do I use Bodo 3
Yeah.
and all of that? But that stuff is now trivial
It's solved.
for an LLM to
Yeah.
do.
Yeah.
And having it all in one place and having it pretty well indexed and cataloged
Yeah.
is enabling like some pretty cool stuff, not just in Earth observation, but also in weather.
Weather. Yeah.
But yeah, going back to the platform thing, like maybe someone still needs to attach compute to Source Co-op, right? Like
Like, it's not enough to just have the data there, grab it, do the thing you need to do, which is how I use Source Co-op.
yeah, maybe it is for most use
Yeah.
cases, but maybe I don't know. You have a premium tier where
Right.
someone would pay like 10 compute plus 10% or
Yeah,
something
yeah,
like that. You
yeah.
know, like as a business model.
Right.
And then like AWS makes money on the compute, but they're also providing the open data program, which to be honest is like pretty incredible.
Yeah.
It's
Yeah.
insane actually.
Yeah. Yeah.
So yeah, maybe platforms do still have a, but maybe it's more like public service rather than like VC backed, going to the moon unicorn business. You know.